Hi everyone, welcome back. Today we are going to see about the fault current calculation in the unsymmetrical fault. So here the determination of fault current calculation using the symmetrical component method. So here in 1918, Dr. C.L. Fortescue is an American scientist. It showed that any unbalanced system of three-phase current or it may be voltage may be regarded as being composed of three separate set of unbalanced vector. One is positive phase sequence component, second one is negative phase sequence component, and third one is zero phase sequence component. Here the positive phase sequence component means an balanced system of three phase current having the positive phase sequence, and in the second one the balanced system of three phase current having the opposite or it may be called negative phase sequence. And a zero sequence component is nothing but a system of three phase current equal in magnitude and having zero phase displacement. This is called zero phase sequence component. And here the positive, negative and zero phase sequence component are called the symmetrical component of the original unbalanced system. So here the term symmetrical is appropriate because of unbalanced three-phase system which will be resolved into the three set of balanced or symmetrical component, positive, negative and zero. So here in this three diagram, the diagram 1, 2 and 3. So here there are three phases IR1, IR, IY, IB, IR, IY, IB. So that is nothing but R phase current, Y phase current, B phase current. Here IR1, IR2, IR1, IR2, IR0. The 1, 2, 0 indicate 1 means positive sequence, 2 means negative sequence and 0 means zero sequence. So it decide whether it's positive, negative or zero sequence. So here in the positive sequence, and this is the current in any phase which is equal to the vector sum of positive, negative and zero sequence component in the particular line. So here in the positive sequence, all the three phases R, Y, B are 120 degree in displacement. All the R phase, Y phase, B phase in 120 degree phase displacement, and the phase shift is R, Y, B. Or YB. But in negative sequence, all the three phases are displaced by 120 degree, but the phase shift is RBY. So instead of RYB, YB's it's interchanged. So instead of RYB, so now in negative sequence RBY. So there is nothing but negative sequence and zero sequence. So in all the three phases, the magnitude and the phase angle will be same. The phase angle will be zero. So this is the IR current is nothing but irrespective of IR1, IR2 and IR0. So we can determine the total current. And the next one, operator A. So here we have to introduce some new parameter, new symbol. New denotation is nothing but operator A. As the symmetrical component theory involves the concept of 120 degree displacement in the positive sequence, negative sequence and zero sequence. So it is desirable to evolve some operator which should cause 120 degree rotation from all the three phases. So for this purpose, a symbol A or it may be lambda can be used instead. So it is the defined as under the operator A is 1 which multiplied to a vector rotates the vector through 120 degree in the anti-clockwise direction. So here the operator A is 120 degree in displacement and A square will be 240 degree and A cube will be 360 degree or it may be called as 0 degree. Okay, so A means 1 of 120 degree, A square means 1 of 240 degree and A cube is nothing but 1 at the angle of 360 degree. And this is the assessment. An overcurrent relay having a current setting of 150 percentage, which is connected through a 400 to 5 amps CT. So now we have to determine the pickup value of the current is whether it's 2.5 amps, 5 amps, 7.5 amps and 10 amps. So put your answer in the comment section, and these are the few reference books for our topic. Thank you.